Yo, what's up, everybody? Welcome back. Today we're working on our collaborative Rube Goldberg machine, and the topic for today is integrating our first chamber. So, context: what is a chamber? What is a Rube Goldberg machine? We want to build this machine where there's a ball and it's jumping around, hitting walls and stuff. But the idea is that there's no real purpose to the machine other than to watch the way the ball moves around in it, right? Um, I want to make a system where we can have complex, we'll call them chambers, where the ball can roll in and out of, and we can just watch it move around, right? So the thought is we're going to have like some sort of like big grid of little areas. And in each area, you might have something like interesting happen, right? So like maybe there's a cannon over here, and the ball like rolls into the cannon and gets like pew fired up the side. Then maybe like there's a planet in here, and the ball like orbits the planet and then gets like shot out down here. Maybe in here there's like a pool of water, and the water gets like siphoned out, and the balls kind of like go with the water. Maybe there's like a portal over here, and the ball shoots into the portal and fires out the other end, right? I kind of want to like allow for as much variation in these chambers as possible. And so what we have, or like what we're working towards, is a simulation where every chamber is defined by some WebAssembly module. The simulation is like running long term on some server somewhere, and we can like peek into the current state of the simulation by going to some website and looking at what like the current state is. So these chambers will have like a rendering API that is run on the client that says like, oh, I have this object over here and it's moving around. Here's how I draw it. And so the WebAssembly module just like poos some pixels onto the screen, and we render those in like a HTTP canvas or HTML canvas. Sorry. So that's what we have here is like an HTML canvas on the right, where a WebAssembly module is like moving this platform back and forth. And then what we have on the left is like the world's most rudimentary physics simulation. So we have like a ball, it falls to gravity, and when it hits stuff, it bounces off the stuff. And so what we want to do is we want to like meld those two things together today and try to figure out like how do we render the, or not render, we want to do like, we want to hook up our WebAssembly chamber into the physics simulation so that it can affect the state of the ball and stuff. So there's going to have to be some component of this that is run like on the server. And then once we have something running on the server, we need to like take the state of our modules and put them up into the client somehow and render the current state as the server sees it. And then we need to like hook up physics to these things. So right now we just have the ability to like draw a platform, move it back and forth. We need to figure out how do we integrate that with like the overall physics system of the entire machine and make sure that like the ball is being affected by the things in the chamber. So that's the goal for today. Try to figure out how to make all that stuff work. Eventually, since this thing is going to be like collaborative and like user generated code is going to run, we're eventually going to need to run WebAssembly modules on the server to ensure that we have like a reasonable sandbox and stuff. But for now, I think that we will probably just run normal code on the server and make sure that it like we compile the code both in WebAssembly mode and non-WebAssembly mode to run the client. I think that's probably what we'll do. I'm not really sure. We'll see when we get there. Yeah, I think let's just get moving. Let's get moving. Let's get moving. So the way this is all set up right now is we have one giant main.zig file because we haven't bothered splitting it out yet. And in here, he's got a thread that is running a simulation somewhere. And in here, I think, let's see, we have like a hard-coded single ball with a hard-coded two surfaces. So that's these two blue lines we're seeing here is the hard-coded two surfaces. So we're going to have to swap out these surfaces for a chamber, probably. Our chamber is probably going to reuse some of the code from these like existing surfaces to handle like collision. So right now we kind of just hard code the collision stuff in our simulation. We're gonna have to say like, hey, chamber, could you tell us where things collide and maybe apply some forces to the ball? Not really sure yet. And then I guess that's kind of it for the start. So let's start by like taking our singular chamber, I guess, and having some sort of like interface to it. So we'll say we instantiate a chamber, which doesn't exist yet, but probably we can just import chamber zig. What is in here? So this chamber.zig, this is the WebAssembly module that's running on the client right now. So it exports some like functions that have C ABI And then like Zig, when we compile it, turns those into WebAssembly like APIs, and then like JavaScript calls into these APIs. So he's calling render and step, and he has got some state that he has associated with this thing. So probably this step function, which is like moving the platform. This is probably what we're going to call on the server side. We probably want to take this state of the chamber, and this is probably what we want to store. The position of this like platform and how it's moving right now is basically all that's in there. Then our step function, which is going to be like applying movement to the thing, I guess will also apply physics. So maybe we will pass in a pointer to our ball here. And this guy can say what happens to the ball as a result. So let's kind of just like play around with that and see where that ends us. Simulation. So we have chamber, and this is not going to be a chamber. This is going to be chamber state, which comes from chamber here. And what needs to be done? I guess we are going to, instead of, so this stuff is like all applying to the ball. We say, hey, can we apply gravity to the ball? Could we adjust the speed of our ball, make sure it doesn't get too fast? Can we move the ball according to its current velocity? And here, this apply collision is probably what's going to get swapped out. We're probably going to say like chamber step with the state of the chamber. Yep. Which means that this thing should actually be called like chamber state or something. Chamber state. And then does this thing get allocated as like a pointer on the other side? Hold on. When we initialize this thing, he returns a pointer. So here we will store a pointer to this thing. And over here, we will just pass it in, not by reference. We will give it the amount of time that we moved. And I guess we're also going to want to give it the ball. And which means that this guy is going to have to take in the ball. Let's do it in the other direction. I kind of want delta be the last argument. I don't know why, it just kind of feels better to me that way. Okay, so now we have to like get this ball in here, and so this is kind of a problem with everything being in main, is that we can't import this ball structure from that side anymore. But we can fix that pretty easily. We'll just make a new ball, zig, paste this shit in here. And I think that he doesn't really have to do anything right now. He just needs these parameters, which means that this like pos2 and vec2 thing need to be split out. Maybe a whole file for this is extreme. Maybe we'll call it like, maybe we'll just split it like a types zig or something. I don't know. I hate types files. I think that's like the wrong way of doing stuff usually, but you know, I think it's like when you make a types file, you're like, I don't really know what the fuck I'm doing. I don't know how this stuff is going to be laid out. I don't really know how I want it to look. I don't really know how to categorize this incorrectly. And that is the exact state that we're in right now. So I'm just going to do it. Fuck it. So we'll kind of throw this stuff in here too. Pos2, vec2. Sure. We need the standard library here. Make this compile. Shouldn't the chamber be called from a wasm interpreter since it uses the wasm allocator? Oh, that's a good point. That's a good point. We're going to have to do some like shenanigans probably to fix that, but you're right, you're right. You are correct. Okay, so we'll kind of like just kind of yoink this shit out of here. And then I think we have everything we need in types.zig. And then we just can say const types is equal to import typezig, and const pos2 is equal to types pos2. This stuff needs to get exported as public. So all of this stuff needs to say pub on it. Boom, 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 boom. All of this is public. Seems reasonable, seems reasonable. Vec2 is vec2, and ball is ball. All right. Okay, so now in our chamber, we can say const types is equal to import types.zig. And we can just do, I guess, copy paste this for now. Okay, now he can take in a ball, and for now we can just say the ball is unused. We will come back to it. I don't think I want this to be an exported function anymore because of this ball. Maybe it's fine, actually. We'll see. We'll see if it gets angry. Ball is not marked pub. Fine. Fine. You're going to be like that. Unknown identifier ball at 263. So this should be self ball. And state is not marked public. So where's that? Oops, what the fuck? There you go. All right. Missing struct field chamber state. So when we initialize our chamber, we need to now say that our chamber state is equal to chamber init, I guess. And then for now we'll say or else return error. Internal error or something. I don't know, it doesn't fucking matter. Doesn't matter. Here we go. Okay, so this is what we were talking, what Mackie was talking about, that the wasm page allocator won't work in this case. So how can we work around this? How can we work around this? Because it would be nice to keep everything in one place, because eventually all of this stuff is going to go back into wasm land. We're just kind of like making a stopgap now to avoid having to like initialize a wasm engine on our server before we need to. Like, we'll get there eventually. I just don't want to tackle that right this second. So maybe we'll do something like var alloc is equal to null. And we will do something, maybe like just in initialize. Maybe we'll call this, I guess we can still call this wasm alloc. And we'll just do something like if I know there's a way to like get the current target. I guess probably wherever this thing is used. Wherever this thing is used, we have an example. Built-in OS tag. Here we go. So we can just say var wasm alloc is a allocator which is undefined. And then when we initialize, we're going to switch on stud built-in OS. I already lost it. What was it? Import built-in target. Was that it? Maybe. Built-in target. Yep, thank you. Here, if we are on, what is this thing? Target OS dot tag, I guess. Where is like wasm in here? I bet you could do this at compile time, somehow a function that returns the right allocator. Yeah, but I think that if I need to like do some runtime initialization of the general purpose allocator, I thought. But maybe not. Maybe not. Okay, wait, let's go back to this thing saying, what was it, stood heap wasm allocator or something? I just want to look again at their example. Built-in target, and built-in comes from built-in. Yeah, okay. And so we can just say, if this is wasm, we do this. Cannot, but this won't be in like global scope, which is a little annoying. I think GPA can be initialized at comp time. That's good to hear. Yeah, how do you get around the fact that like global variables, can you not like conditionally create a global variable like this? Because this is just not going to be in global scope, which is what I would have wanted. Zig compile time if global. What does this guy do? That's not really what I want. You can break out of scopes with labels. Oh, so you do like you create like a allocator. No, I'm not quite seeing it. Not quite seeing it. It's okay. It's fine. We will do comp time function get allocator or something. And so we'll return a std mem allocator. I think you can put the comp time here. Not really sure though. We'll see. Maybe it's like this. And can we say like var alloc is equal to comp time? Yeah, you need to do one of those break blocks, I guess. That does feel like the most natural way. Zig language reference. Block. Here we go. We'll just do this. We'll do it this way. Wasm alloc. And then we can do this. If this is the thing, we break width to the block with std heap wasm allocator. Else, we say like var global variable. We make a global variable in this frame of reference, which you can do by saying like const s, we'll call it, is a struct. And then we say we have GPA is a std heap general purpose allocator. Like this or something? No, var GPA like this. Yeah. Here we go. So this thing is like global now, even though it's in this local scope. And then we can just say break block s dot GPA allocator. There we go. That feels right. A little bullshit, but I think that works. Because now I was worried about like the reference to GPA going away, but I think that if you do it this way, it's fine. Let's see if that like fixes the compiler errors. Switch on type target. Oh, oops, I didn't mean to do this. Okay, that's better. No symbol log wasm. So I guess in here, unfortunately, just to like get around this, we're gonna say export log function log wasm that takes in const u8 and ln. And for now, we will just do nothing with that because I don't think we're gonna use this here. We just need it to be there so we can compile. Why can't you just use an if-else block while signing? I think that it doesn't work that way. I don't think that like if you have multiple statements within an if that it like auto returns the last thing. So I think you have to do this like break thing. Unless I could somehow like move this outside, but I just don't think that's that straightforward. What I'm in the video editor. I got it to the point where I could use it to edit videos. Like it was like working well enough that I could like dog food it a little bit. And then I tried making some videos with it and I didn't like any of the videos I made. So I just immediately lost interest because I was like, I don't like any of the cut down versions of my VODs. I feel like I have to sacrifice something and I don't want to sacrifice anything. So I just was like, I guess I won't cut down videos. Maybe we'll go back at some point if I decide to take a second run at it. But now the thing is just completely useless to me because I'm not going to use it. So it's done for now. All the code is available if somebody wants to, continue working on it. But, you can't do multiple statements, but I think you might not do them since I don't think you need to save the GPA variable. You definitely need to save the GPA variable. I'm like 100% sure on that. Because this allocator function returns a pointer, like keeps a pointer to the GPA. So unless this GPA is like internally creating some sort of static memory, which I don't think it is, like this allocator will try to reference the memory that this GPA was created from. And so if you need it to like stick around, you know? Because like that's where it tracks all of the pages that it's allocated and shit. Okay, so we compile. Do we run? Do we still run? I don't think that we should have changed anything. Yes, we're still chilling. This feels broken, which is kind of interesting. Oh, because the step function isn't working anymore because we changed its API. So if we go into index.js and just change step here to take in a null pointer to the ball, then this should work again. Yeah, there we go. We're back. We're back. Okay. Okay. So now we want to go back to our main and we want to step this chamber simulation, which we are. Okay, so really just to get back into the current state, all we should have to do is add some sort of way to like serialize and deserialize the current state. So how do we want to do that? Maybe we want to do something like we have some function. Init, I guess the init function is going to come from something. We're going to have two init functions. One that's run on the server that initializes it just with nothing, and then one on the client that initializes it with some sort of state. So we'll call this init from our load, maybe? That seems reasonable. And this is just going to take in, like, say, a save buffer of some bytes. Except it can't do this. It needs to take in a pointer and a length. So we'll do this. Because it is an exported C API that's going to be called from JavaScript. This guy's going to basically just say, like, what's in here? We will allocate our state. I think that makes sense. And then here we have to just take the stuff out of the save buff. So we'll just say that our platform location comes from... I wonder if we can just get away with, like, stood mem from as bytes as value. Like, I wonder if this, like, F32 is guaranteed to be Little Indian. Like, I know that you're not really supposed to do it this way. But I think in the wasm machine, they're guaranteed Little Indian. I think. So we can probably do something like save buff 0 to 4. We'll come back to this. And the direction is going to be a direction. And we're going to say stood mem bytes as value. Here it's a little trickier because I don't think that we're like guaranteed that this has like a specific repr, but I think we can just say that it's a U8 and then everything just kind of comes together. So we'll just say direction save buff 4, which might work. If you move the GPA out to the top level, then you could just do const alloc as if wasm alloc else GPA allocator. Yeah, but I wasn't confident that I could make a general purpose allocator in wasm. That's what I wasn't sure of, which is why I did it that way. But I'm sure that's like workaroundable. I just didn't know what to do. Okay. This is definitely sketchy, for the record. But we'll just run it. We'll run it and see what happens. Here we're gonna say if save buff len is not equal to 5, we return null, because that's not the right thing. Not the right thing. Which means that now I can make a function save, which doesn't need to be C style, because we're calling it from Zig right now, although later we will need to. Pretty sure lazy analysis means it won't matter. Oh, that's a good point. That's a good point. Okay, so we're going to take in a state, and we're going to return a const u8. And which means we also have to take in some allocator, but we're using like our global allocator, which is fine. Although this thing will have to get freed. So I guess for now we'll just do this. That's fine. Which is a little confusing. We're kind of mixing and matching allocators here. But I don't really care. Do not really care. Okay, so here we're gonna do like just the opposite of this. So we're gonna say, actually we don't even need the allocator here actually, because we can just say that this thing is 5 bytes long. We know how long it is, which is makes this fine. Is this not valid? It's like this. I see. So we can just do var ret is 5 u8s. Yep. Ret 0 to 4 is stood mem as bytes. How does this work? This gives me as bytes, gives me an as bytes return type, which is going to be copy pointer attributes. I think it's fine. Ret 0 to 4 is equal to stood mem as bytes state dot platform location. Is that how you do this? Invalid left hand side of assignment. Stood mem. I guess it's just mem copy. Yeah, that makes more sense. We mem copy this stuff into that stuff. And we can do ret 4 is just state direction. And then just do int from enum. Chillin'. Does that compile? Nope, obviously not. So this is mad at access field pointer while int is active. We need this to be a pointer, I guess? No? Am I fucking mental? Am I doing something stupid? Is it as bytes? I also saw 2 bytes. 2 bytes. Given a value returns a copy of its bytes in an array as bytes. Given a pointer to a single item returns a slice of the underlying bytes preserving pointer attributes. Okay. Yes, what's the fuck is the problem? And this should also return ret, actually. Access of field pointer while field int is active. Oh, it's because it's this one. No, this is int from enum. Okay, let's just do this for a second. Make sure that everything else compiles. Oh, it actually doesn't like that from somewhere else. Where is this happening? Where, like, this stack is so short. This is in the wasm build. What the fuck is going on? Copy pointer attrs, bytes as value return type. Oh, it's this down here. Oopsies. Oopsies. Given a pointer to an array of bytes, returns a pointer to the value of the specified type backed by those bytes. Oh, this one probably has to... Oh, it's this thing is a single value. So I just do this. Enum from int, like this. Boom. And this thing has to say that I'm a direction. There we go, better. And then 82 bytes to value. We want to copy it out. There we go. And then this stuff was probably fine. Let's see. Yep, chillin'. We compile now. So now we should be able to... this is going to give us like a buffer of shit. So I guess we can do like chambers, save, self, chamber state. And I guess this actually happens on the thread that is returning HTTP responses. So over here, this is taking too much shit now. So let's just take in like the whole... Oh, we're copying stuff out, that's why, okay. So I guess here we'll say const chamber state is equal to simulation context chamber state, and we save it. We save the current state. Then we pass in the chamber state here when we construct our HTTP response. Chamber state like this. And then here we're just going to add the chamber state here. Yeah. And all we should do is down here write chamber state is equal to chamber state. And everything should happen for free. Everything comes for free, I think. Fuck. Right, because now it's actually compiling that function and it's mad because chamber zig line 62. He doesn't like this. What doesn't he like? Is not an indexable pointer. Const star 4 U8. Oh, is it like this? Is that why? It is. Okay. And then this thing here is actually supposed to be a bunch of U8s, I guess. We'll call it a const U8 like this so that it auto slices, so I don't have to know the size everywhere. Okay. So now if I run this thing and we look at our responses, we should see chamber state in here. Very nice. Very nice. And so now we can just adjust our JavaScript so that when we init this thing, we actually initialize from state. Oh, this is kind of fucked. This is actually kind of fucked. Because this is going to allocate. This is going to allocate. We never free anything anywhere. So we're going to have to fix that. We're going to have to do something like pub export function dinit takes in a state pointer. And this is just going to call wasm alloc destroy state. That seems fine. Actually not a problem. Then over here somewhere, we're not going to initialize our chamber state here. We are going to initialize our chamber state basically every frame. So here we're going to say like, if chamber state is equal to null, or is not equal to null, we say, hey, let's free that bad boy. Then we're totally free to allocate a new chamber state, which we call load now. And this is going to come from some buffer. So I think that we need to like convert our JavaScript array into a uint8 array. Or I guess we need to like copy it into wasm memory somewhere, right? Because like the wasm module has its own memory that it manages itself, and when we have pointers in wasm memory, Yeah, he only knows how to work with external data. So I guess what we'll do here is actually instead of taking the buffer and the length, we can take in a pointer to some allocated slice that we had allocated externally, internally, from the wasm module, whatever the fuck that means. And then we have the same problem where we actually have to free this shit. So here we'll take in a pointer to some U8s. This will return void. And here we will wasm alloc free the data that it's pointing to as well as the pointer itself. Which makes for a bit of a pain in the ass on the JavaScript side, but we'll make it work. Okay. So we need to like allocate the state size. So chamber simulation state, chamber state, is it called? Chamber state. How do you get like the length of array length in this language? I think that's right. And so we'll call this const chamber save. And then we need to free the chamber save. So we're gonna hope to God that we don't accept, like, throw an exception here, and then we'll just type free here because we're being fucking lazy. And then just between those things, we copy the data into this thing and then feed it into the wasm module. New uint8 array. And we have to copy whatever's in our JSON. So how do we do this? From typed array. Yeah, okay. So we can just it's typed array. We'll see what happens if we just pass in simulation state dot chamber state. Surely this won't work, but we can dream. No, we don't even want to do this. We want to say chamber save set. Oh, right. Okay, sorry, my brain. So this gives us a pointer in WebAssembly land. We want to extract the data, the pointer, and the length from that thing. So we say slice pointer. Yes. We get the slice pointer. And this is an offset. This is the yeah. And then the length is, let's stick this in a fucking scope so that we don't get lost. And the len is same thing, but slice len. Yes, we make a uint8 array around this thing. So we say chamber instance exports memory from the offset and the length. And then we say array set with this. I think that's right. But we will see. And then we just need to actually get the thing out. So chamber state is equal to this thing loaded with the chamber save. Wow, that's awful. What a pain in the ass. But it's okay. Chamber is equal to null. Then we go through all of this and chamber is set. This stuff goes away. And we should, oh shit, we can't call it this. It's, fuck. We'll call this chamber state like this. Yes. Okay, I think that all works. Maybe. What's the color scheme? It's, a kind of fucked up situation where we have the Sonic Eye color scheme, but in Alacrity with term GUI colors off, which just makes it look really weird. But That is what it is. And I'm too lazy to fix it, so we just live with it. Okay. So... Oh, fuck. I'm in the wrong fucking function. God. Oh, no, I'm not. This is fine. Nope, change my mind. We're going to maybe take this out to the other canvas for a second, because that's where everything was before, and then we'll just also fetch the simulation state over here, just for now. Okay, so we get the simulation state. This needs to be an async function. We extract it, we do this thing, and then instead of stepping this thing, we never step it here, and then we just render with this newly created state. Oh, and I guess this does have to still stay global because we are just freeing every frame at the beginning of the frame, which is a little silly, but we'll live. I think it's fine. I think it's fine. I think that might work. There's like a chance that it works, which is good enough for us. Chamber zig 81. Whoa. Oh, I see. This is supposed to be a star like this. And then this should be like this, I guess. No? No. Oh, I see. We need to put some dot stars here. That's why. Do we build now? We build. We're running. It's fucked. Source array is too long. So can we look at, like, how do we see what the fuck is going on here? Do I not get to see? Like, there we go. So chamber state is length 5. Array is length 0. So we fucked up here in some way. Offset is a big number. Length is fine, which is reasonable. Maybe we have to write buffer here. God damn it. Dude, what a... Like, I can't believe this language, man. The fact that it doesn't, like, give up when you do something, like, just obviously fucking wrong is very frustrating. Very frustrating. Yeah, I was just supposed to write buffer there. So I just gave it the wrong type, and instead of it being like, whoopies, I don't know how to work with that, it's just like, oh well, we'll keep going. And it's like, why would you keep going? Keeping going there is insane. It's actually insane. Okay, so there is at least somewhat of a good sign there. We see movement. It's glitching the fuck out, which is not good. But we see something. Why is it glitching the fuck out? Raced. So there could be something going on here where we're... Do you give up completely when you make a small mistake? Shake my head? No, I mean, it's just frustrating. You just want to run the TypeScript type checker every time you build Zig just so it checks types in the JS. That's not crazy. Not crazy. I should learn eventually to do something more reasonable with the JavaScript stuff, because I kind of just shit myself and do whatever makes sense. And eventually that won't work anymore. That's a lot of requests. Yeah, it's going at like 60 frames per second, which is like fucking stupid, but it's fine. It's fine. Okay. So that's like a good sign. I wish we should figure out why it's busted though, and how it's busted. So it looks like when it's busted, it is flickering to the left-hand side. So maybe we could look for when that happens somehow. So that would be a floating point position of the buffer of 0. Let's see if we can detect that. So in our Zig chamber, when we load the state. Let's say if platform lock is equal to 0, let's just print something. So I think that we have a print function here. I did make one. Nice. We should just be able to say like 0 platform lock. And if we refresh this, do we see that happening sometimes? I think we do. It's hard to tell because it doesn't change. Can we like increment some counter? Var counter is equal to 0. So usize. And then we'll write D here with the S counter. And then here we'll say S counter plus equals 1. Then we should at least see some movement in the console, which will... Yeah, we're definitely detecting that, which is good. So now we should be able to say, I think that the save buffer itself will also be 0 in that case. So I think we just say, let's print out the save buffer here as well. Like this. Yep, so the buffer itself is also full of zeros. And we can then maybe try to look for that case. So maybe when we receive our response, we should be able to say over here, if simulation state, chamber state. Can you like array slice in JavaScript? How does this work? Slice. Zero to 4. And if this is equal to 0, 0, 0, 0, which I actually don't know if this is going to work because I don't fucking know JavaScript. That's okay though. We'll just say console log 0 chamber state. This condition will always return false. God damn it. JavaScript compare arrays. Compare slice. Compares references, not data. Compare array content. Jesus Christ, man. What a fucking garbage language. Array 1 dot... Oh my god. Oh my god. Oh my god. This guy's just JSONifying it and comparing the strings? That's so fucking brain dead. That's so brain dead, man. Oh my god. That's so fucking stupid. But okay. 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 Okay, so interestingly, we're seeing zeros in the wasm, but we are not seeing it externally. However, there's no guarantee that I understand this correctly. So we should actually maybe just log this unconditionally, just to see what it looks like. Because I don't know what the fuck I'm doing. Okay, yeah, so we are seeing non-zero input that is getting parsed as 0 in the wasm. Which is kind of interesting. Also, I guess I don't need to JSON stringify here. I can just look at the slice itself. What is happening here? So it's usually printing an array, but here it's just doing like some... Is that log this? Like, how come every once in a while it's usually logging like an array of 4 elements, but here it's like occasionally just printing out something else. Like, what the fuck is going on here? Let's make sure that this is the right log. So we'll say chamber state, like this. Okay. So can we, maybe we hit the debugger there, and then JavaScript will stop, and then we should be able, where the fuck, oh, here it is. Fuck. It's not gonna work like that. But I want to see if any of the like actual responses are like that stupid. But I don't really know how to debug this. Are you checking it after de-editing? It seems like possible, but oh. No, simulation state here. Chamber state comes to the simulation state, chamber state slice. So there should be nothing wrong there. It must be like thinking it's a string in some way. So maybe on the JavaScript side, or on the Zig side, it's serializing it as a string in some cases instead of a bunch of numbers, and that's causing problems. Maybe. Is there a way to easily check that? I guess we have. Here's what we'll do. In our chamber Zig, we will just 174 shouldn't DNet bean it. No, that's intentional. So it's because last time, like, so we're doing like allocate some state, put like render, and then next render deallocate previous state. That's what this part is doing. So this is correct, as far as I understand. But I've been wrong in my life many times, so we'll see. I think that what I want to do is I want to go into the chamber Zig, and we can just do something that's like, is 0. And we will return platform state platform lock equals 0. Simple. And then over here, we should be able to say down here, if chamber this shit, if it is 0, let's see if this at least logs correctly. Yeah, so we're seeing this log in the right spot, and now we can breakpoint on that in here, and then we can look at the state of our thing here. Boom. Okay. So what the fuck is going on? What the fuck is going on? Chamber state save is undefined. What? Oh, because we're not in that block anymore. God damn it. Okay, that's fine. We can fix this. We'll do it here. Refresh. We don't want to breakpoint here anymore. We want to breakpoint here. Okay, and then here we have chamber save has this data that came from the simulation state, which is yeah. So here chamber state is a string, which is not good. And this, it comes in as a string. So that's probably yeah. So usually it comes in as array, but occasionally it's coming in as a string, probably because Zig is like auto casting that shit and not figuring it out. That like it's like thinking like, oh, this is a constituent. Constituents are strings, so I'll serialize it as a string, which is not what we want. It's causing bad behavior. So this would be in our response JSON. How do we stringify options? Yeah, we just do this. Emit strings as arrays, I guess. Emit strings as array equals true. And then hopefully that fixes it. Does look like that fixed it. Okay. Okay, fucking weird, but fine, I guess. Is there a way to encode this stuff in a way where it won't try to do that? Why, like... Let's see. So... yeah, so he's doing this, I see. So what was happening is this UTF-8 valid slice was returning false, and so it was writing it as an array. But it goes, if it's possible to write as a string. Okay. And it looks like, so if we wanted to get a little bit more granular with that, say there are actual strings that we want to emit here, then we'd be in fucking trouble, and we'd have to like write like a more intelligent JSON serializer. But we don't have to do that right now, so we're not going to. We're chilling for now. Eventually, this will probably come up again, but we can save that for later. Save that for later. So this is done as well. This is done as well. And now we can look at trying to actually integrate these two things together. So what does that entail? Logged and say that was some cathartic debugging. Hell yeah. Nice, nice. Glad to provide you some catharsis? No way that's the right word. Catharsis. Maybe. Cathartic? Yeah, okay. Wow, catharsis did not sound right, but I guess we guessed right. Look at us go, knowing English and stuff. Okay. Okay. So let's do some physics. Yeah, okay. Let's do some physics. So, what happens over here? When we are running our, well, first actually, let's git commit, git add source types, rm source ball, git commit -m smiley face. Let's double check that by removing that thing we didn't do anything fucking stupid and break anything. Nope, we're chilling. And now we should be able to do some physics. So this apply collision. He iterates over collision objects, which are just surfaces, which are lines with normals. He says, if I go through that line, change my velocity and my position. How are we going to handle this from within a plugin? Let's think. So, probably, my gut says that the math for like doing the bounce only depends on the normal of the object. So probably like the generic thing to do here is like plugins are going to have like any arbitrary shape, right? And if the ball hits right here, we're going to basically want to say, hey, we collided, and this is the normal at the point we collided. And then the physics system can like handle applying the forces from that normal. I think that's pretty reasonable. I think because like I don't think that I want to like force people in our plugins to encode this as like a bunch of straight line surfaces. I think that's silly. And then that also means that the plugin gets to own the collision checking logic, which I think is probably okay. We could provide some sort of functions to do intersection tests for like common objects, right? Like it'll be pretty clear that if we want to do like a rectangle, that like our collision check with a ball is going to be like, is ball plus radius in any direction within this thing? Probably you could do something like point towards the center of this rectangle, check if this point is within that bounding box or something. And then we could maybe provide those functions like as a library, I guess. Right, like you don't really want I don't think I want my like wasm plugin calling out to functions that we provide within our app, because that means that like the wasm engine will have to like call out to like C bindings, and like every time we do a collision check, we actually have to like do a call this way, and we don't have any ability to like inline the checks and stuff. I would imagine that collision checking generally should be pretty like cheap in terms of like code space, like i.e. like should be fairly inlineable, and probably performance goes up a lot if it's inlineable. So I think that probably what I want to do is like expose a function to the module like almost as a separate library, right? We would probably at the end we'll have like lib physics, and this will have types in it like vec2, pos2, ball, and like apply collision. Then when we like compile wasm modules, people can choose to link against libphysics if they want, which should be most people. And then we'll have a bunch of duplicated physics functions within our wasm modules, but hopefully they get like compiled out to the point where like they would have been inlined anyways, so it's not that big a deal. Like hopefully like the amount of like actual code size that this creates is like very small. That would be my hope. I think that's reasonable. It feels pretty reasonable. Right, because like vec2, pos2, or vec2, pos2, and ball, these are all just like a couple floats. So these will just get compiled into like register offsets. Apply collision is just going to be like a couple functions, probably. So I think it's fine. I think that's fine. Which means that for now we don't need to go all the way here yet, but it just means that we can think about like what APIs we want to start working towards and kind of nudge in that direction. So what does this apply collision function do right now? It looks at like a surface, where a surface is defined as just two ends of a line. He extracts the normal from this thing. He uses that normal to figure out where the ball will collide with the surface. And then we do some checks to make sure that we're like actually colliding. So this part will probably be owned by the plugin. And then this is where all the interesting math happens, where we look at where the ball traveled and calculate where it intersected with the wall. Let's think about this. So if we're saying that we have like A, B, this is our like line segment. The ball came from here and he went down like this. Boom, boom. And we're kind of saying like, okay, we collided here and our normal is this way and our collision point is here. Apply stuff. Can we, I guess we're kind of, we want to change this API probably to, this intersection point thing is actually still fine to live here, I think. It's the logic of what we do with that intersection point that makes sense to be in a library. So that's this stuff here, where we say, hey, we collided at this point. Here is the changes that we have to make. Okay, that makes sense. Maybe we want to like provide this surface as something that like wasm modules can interact with. I think that probably makes sense. Then, because then they can reuse the math that we did here. Yeah, let's do it that way. So plugins will be able to implement their own physics behavior. Yeah, I think that I want like by default for it to be consistent. But I think that there's no way around with the amount of things that I want to be able to happen for plugins not to just let them go crazy. Right? Because like if I want to do something like a chamber where you have like a portal and like the ball goes in here and then shoots out here, or like something like some water that the balls like float in and they kind of like bob up and down or something. I don't want to like say that like I have to specifically support both of these cases. I kind of want the plugins to be able to make those up, so because then that allows like user creativity without me having to have the foresight to implement everything. But if somebody is just making like something that's like, there's like a triangle and like a piston that goes up and down or something, and the balls like sit on the piston, and when they get up to the top, they like roll down the hill or something. I want that to kind of at least feel consistent. So if people are using like the normal world, I want the normal world physics. So I think that makes sense. So I think for now, let's just kind of move this surface object into types. And for now, maybe what we'll do is we will model our moving platform as just like a single surface and see what happens. So I'm gonna hold on. The last piece here. The last piece is that we need to import surface here. Const surface is equal to types surface. This needs to be public. Okay. And this stuff needs to be factored out as well. Does every chamber have the same input and output locations? I think that I'm gonna like say that they all live in the world of 0 to 1, and then we will probably tell them their height. Or they will have to just know their height somehow. Maybe that'll be encoded somewhere. Yeah, and then we'll just have to line them up on a grid, I think. So we'll call this apply collision. And let's just see what inputs and outputs the thing is expecting. He's definitely expecting a ball. But what else? The object normal. Normal, which is a vec2. And then also needs the intersection point. Intersection point. And it also needs... Well, we can infer the offset from the intersection point based off of the ball position, I guess. Or we could say that the intersection point is relative to the ball. So we can almost call this like a intersection ball intersection direction offset. So like where relative to the center of the ball did we collide? Then we can derive const ball line or ball this thing. Oh, he's just saying the ball position is... they need to know where in the world it hit, actually. Yeah, so we actually do need to do ball line intersection point. So this is going to be a position in world space where the ball collides. That's like, if we have our coordinate system of like 0, 1, 1, 1, 1, right? Like the ball is here and we're colliding right here. We're going to provide this point as part of our API. Okay. Okay. And Fuck. Maybe we do need to provide the something else as well. Because I think what's happening here is the API is like, the ball was here. The ball is now here. We are providing this point, which is where we collided. But like, it's kind of confusing about like where that is relative to the center of the ball. Right? But I guess like we can maybe assume that that collision point is somehow related to this normal of the surface. But it might make more sense to just feed it in. Let's just do that. That's fine. And this is a vec2 probably. Okay. And I guess we have the delta as well. Yep. How much velocity to add. How large this time step was. None of this that doesn't feel like a good API, to be honest. But it's maybe enough to get us moving. So let's start here by just saying types apply collision. We'll just pass everything in here and make sure everything feels okay in the normal simulation. So this is going to take in all sorts of stuff. The ball, which I guess is just ball here. The obj normal. Ball line intersection point. Ball collision point offset. And delta. Okay. So hopefully this feels okay, and then we can just move on. Okay, so here we need to wait for this guy to reload into a sane initial state. Okay. Yeah, that feels okay. Feels okay. Doesn't look like we like heavily broke anything at least. Okay. So we'll go into our chamber now. And I guess what we'll do is on step, we will create a surface that is made out of our platform. Seems reasonable. So here we'll say surface is types surface. And I guess this is just 2 points. So this is A is equal to some pause with an X and Y. So this is going to be X position is the platform location minus the platform width over 2. Yup. Its Y position is just the platform Y. And the other side of the surface is going to have the same thing, but it's going to be plus the platform width over 2. Okay. Oh, you recommend NixOS? I like it. I like the ability to have my whole operating system defined in one configuration file. But I don't think it's for everyone. There's a lot of pain that comes with it. If you're not familiar with like linkers and build systems and stuff, you might run into some problems because you kind of have to understand like the model of how Linux executes things to understand like why you downloaded some program off the internet and just won't fucking work, and you need to patch the elf to make it work. You need to run under like Steam run. Like there's all sorts of scenarios where a piece of software will like assume that you have a reasonable Linux file system that you just don't have. So definitely try it. I think one of the benefits of NixOS is that you can run it in a virtual machine, and then once you're happy with it, you can just copy paste your virtual machine configuration to your desktop, and then everything like boom, it's just the exact same, which is sick. But yeah, I don't know. It's one of those things where it's like Vim, like Tmux, you know, I'm not gonna like Rust. I'm not gonna tell people to use it because I don't want them to like be mad at me when they're like, "What the fuck?" It's hard. right? Like, it feels good in some ways, but it comes with pain in other ways, and you just have to understand that. Okay. Okay. So, can we just copy paste all this code? Maybe we should just copy paste this. I'm not really too happy with this, but maybe we can use this as a starting point. So we'll say we'll just call this obj here, and then everything might just work. So if we are above the line, if we are below the line, we might have collided. Then we do all of this stuff here. All right. Ever have problems with lack of package stability? I mean, I've had to package stuff for sure, right? Like sometimes there are a lot of packages, like a lot of them, but sometimes you might have to package something yourself, and that's not the end of the world. Stability, I don't know if I would notice. I haven't like, I think that I've run into stability problems on every operating system I've ever used, so I don't know if there's like, I don't know if I can say that it's better or worse. I think that it's a little better than Ubuntu. So in my mind, like Debian-based distros always kind of pissed me off because you would like you just don't like knowing what's happening on your machine is like kind of difficult to me on those machines because it's like you just install some software and you have all these services running and you don't know what any of them fucking do, and like you install Nginx and all of a sudden Nginx is running and you're like, I didn't tell it to start running, I just wanted it on my computer's file system, why the fuck is it running? So the fact that like on Nix you have this defined config and you just read the config and the computer's not going to do anything that's not in that config is like kind of nice. But yeah, I don't know. No, I'm not going to show my Nix OS configuration file. I'm going to leak like passwords or something by doing that. Like, I'm going to like fucking like leak encryption keys, passwords. It would be a disaster. Okay. So is there anything I have to do in here? Might be fine. Might be fine. So now I guess we're going to not call apply collision anymore, which is using our like thing, and he's just going to automatically have that stuff applied through the chamber step. Fuck. Pointless discard of ball, which is reasonable. We do want to keep the ball there now. And now let's refresh and see what happens. Oh. Hold on. Oh, okay, so there's okay, that's actually pretty cool. This is working. But there are definitely some bugs. But let's push it all together into the same we'll fix our canvas rendering so that we can see it all in the right place. But I think it's working, and we just have a bug to fix with collision checking. That was kind of present before that we just never got to. So before we had like two canvases where we were rendering the chamber in one and the ball in another. Let's just render the ball on the right side, I guess. Yes. So we'll kind of like take this stuff, copy it over here. This will all get cleaned up later, guys. Don't worry. Don't worry. This will get cleaned up. But for now, we can just kind of copy paste some code around. And I think that should end up with the ball rendering on the right half of the screen. Nice. Okay. It would be nice to have some. Maybe we keep these collision surfaces underneath as well, actually. Because the ball is only getting vertical movement. Or maybe we just initialize it with some amount of horizontal movement. Oh, which we actually do right now. It's just when it has horizontal movement, it just gets kind of boring. Okay, let's yeah, I'm gonna add these V's back in for now, actually. Because I think that just makes for more interesting motion. So here where we commented to apply collision, we'll just do that as well. Okay. So we're mostly chilling, except for the fact that the collision, it basically, anytime it goes under the platform, it immediately fires itself to on top of the platform. which is not good. It also seems like the position of the platform is not being marked correctly. It seems like the platform is like a little bit higher in the world. Right? Like, what the fuck is going on here? Oh, but that might be like it's under the platform and just jumping itself above or something. Yeah, not 100% sure. But we're definitely closer. We're definitely closer. That's pretty cool. That is pretty cool. What if we, in the chamber, just add a couple more surfaces, to like the ground and shit? Will that help us? Will that make it clearer, easier to debug? It might. No, it won't. I'm trying to figure out what I want to do here. How to like debug this like physics bullshit. Okay, so I think the problem, there's definitely this problem where we have like a surface with a normal pointing this way, and we do this check to see like did the ball end up like behind this surface? So if like the ball kind of goes through the floor like this, we go like it's in this box here, which means that we need to push it back out. And then what ends up happening is we don't actually check if it crossed this surface that frame, which is a mistake. So I think that we just have to do like a little check here where we check for collision by saying, hey, is the object, what is it saying? Is the ball line intersection point between the bounds of this? And what it's doing, I think, is it's like kind of like projecting. So say the ball moved like this. Like on this frame, the ball started here and he ended down here. I think what happens is we go like, given this velocity vector, where would it collide with this line? But it doesn't do any checks on like the length of the vector. So I think all we have to do is just make sure we're like in the same way that we're checking if we were within these bounds, right? Because like we already have this check where, you know, if the ball dropped like this, we make sure that like if it's not within the bounds of this surface, that it doesn't show to shoot up. I think we just have to do the same thing with the velocity vector. So basically just want to say, so first of all, I think we actually have to do vertical collision checks here too. We did this thing where if you have a surface like this, you have like one y position for every x position. So if you know that the intersection point is like here, you know its x position is like 0.4 or something, and this is 0.3, and this is 0.8. But on a completely vertical line, like we have for velocity sometimes, doing like that x check doesn't make any sense, because this is gonna, like your x bounds are so short that like any imprecision will result in it missing. So I think we also want to check if it's within y. So we can just say, it collided if we are within the x bounds or we're within the y bounds, which is a little confusing, but it's because we want to make sure that like any imprecision kind of sorts itself out. And then we just do the same thing for the velocity vector. So we want to know, where was the ball at the start of this frame? Which is information that I don't know if we have. We can kind of reverse it from the ball velocity vector and its position. But I don't know if we want to do that. We probably want to like actually... Oh yeah, it's probably fine. Because... Yeah, that's fine. That's fine. Well, we'll just make that assumption for now. We'll live with it. So here we'll say ball initial position. Do we have that somewhere already? Ball collision point. No, okay, so we'll just say const ball start pause is the ball position, add the ball velocity multiplied by the negative delta. Yeah, that makes sense. That makes sense. And then we'll just say that is this all together? So if we collided with the surface of the object and we were within the step of this thing, I think. So like ball line intersection point dot x is greater than the ball start pause x. Yep. And we're saying that this is not equal to this thing, which is some bullshit. So this is the current ball position, I guess. And this like Boolean logic is like some tricky. So what we're saying here is like, if we see like a surface like this, you know, he comes from here to here. If the ball is here, A is greater than ball and B is greater than ball. And if the ball is over here, B is less than ball and A is less than ball. And so we compare A and B to ball, and we say if they are different, then it must have been between. So that's what this like bullshit not equals is here saying. And I guess we just do the same thing here again, where we check both X and Y. So this is ball start pause and ball pause. Yeah. Okay, what's it mad about here? Zig build. Undeclared identifier ball pause. Oh, ball dot pause. My bad. That might do it. It might just fuck shit up even more. But we can just run it first and then see what happens. Because maybe it'll just work and we don't have to think anymore. I think that's working. Except for the fact that the rendered position of this line is a little bit wrong. So what is going on with that? What is going on with that? So somewhere we have the platform Y norm, which is being used in physics. We are supposed to normalize it relative to the width, not the height, in the rendering. Because the way that we set up our coordinate system is we don't want to worry about, we want to make sure that, like, the world is square. And so if we had like a rectangle like this, and we we set the Y position like 0 to 1, and this is 0 to 1, then all of a sudden like the whole world is squished vertically, like people playing CS. You know, all of those Counter-Strike pros who play on stretch resolution for some fucking reason, it would look like that. So instead, we want to do it so that we have like 0 to 1 on the x-axis, and then this is just going to be like 0 to 0.3, 0 to 0.5. It like totally depends on what we're actually rendering, but the world is going to be scaled relative to this. And then everything should stay square. And now let's see if the ball kind of lines up. Oh, there we go. Okay. So I wonder if there's a way to make this a little bit more interesting. Well, I guess we could just put the platform lower to give the ball more time to collide. Oh, yeah, that's fucking working. That's definitely working, though. Okay. So what's the play here? Let's try moving the platform down a little bit. So we can look at chamber, and let's just move it down. Move it down. So platform Y norm, we'll just put it at like 0.1. Maybe a little higher. Okay. Okay. I'm pretty sure that's working. Pretty sure that's working. Now, maybe it makes sense to like construct a simulation state where this like it forces into something more interesting. Maybe we'll move the platform up and down and see what that does instead of moving it left and right. So here we can just probably change somewhere an X to a Y. Probably. So here we can invert Y and X. And then on the rendering somewhere, we also have to invert Y and X somewhere. Oh, this is gonna suck. It's interacting with both boxes at the same time. Yeah, that's intentional. But we can turn that off actually. Let's turn that off just to see. But now it's kind of sucks because like it just falls off the screen. Right? But I guess maybe that looks sane enough for now. Can we like drop it in the center? Maybe we drop the ball when we randomize its position. Let's just center it. And call it a day. Maybe we'll see what that looks like. Oh, and then probably let's reduce the timeout here to like 1 second so we have more chances to hit the platform. He keeps missing. Okay. I'm trying to decide if there's more I want to do right now. And I think that probably I just want to spend some time cleaning this stuff up. But I think that we kind of got like the base of it down. So we have a chamber that is applying some sort of physics to the ball. We have the state of the plugin being sent over to our client. The client is parsing that state and like instantiating the same code but in WebAssembly and using that to render the position of the platform. So I think I'm pretty happy with that for now. This is gonna have to get cleaned up, but I think we have all the pieces in place to actually make like a more complex chamber. Oh, we also fixed the collision checking with the platform, so it doesn't get like immediately get like split up. I feel like a WebSocket would make sense here. Yeah, probably. That is a lot of network requests. But probably I think that I'm gonna be fine with long polling, to be honest. I don't really see a reason. So like the benefit of WebSockets is that you can like push data from the server to the client, right? But like the way that we did this before WebSockets were around is that you just like open an HTTP request and then like the server just doesn't answer for a little bit and then the server answers at some point and then you immediately ask again. That's probably good enough for this thing. I don't think that we need to take on the complexity of WebSockets when that's so easy. Does the moving add horizontal movement to the ball? We are going to have to fix that eventually too. So right now our physics model doesn't have the concept of friction, which we will probably want to add. But yeah, I think I'm going to call it for today. I'm feeling a little tired. I think that we've made some form of visible progress, and I don't think that I have like a good clear idea of what I want to do next. So I'm going to like soak on that overnight and then come back tomorrow, I think. But yeah, I think this is good progress. Pretty good progress. Happy with that. So I'll do some cleaning off screen, come back tomorrow, and we'll figure out what we're going to do. Thanks for watching, guys. If you liked what you saw, we stream most days at around 2 o'clock Pacific time. Right now we're working on this Rube Goldberg machine, but there's a lot of other stuff around on YouTube if you want to go check it out. So that's organized into playlists. You might see like operating system, what else is QR code decoder, zlib and zig, file system, video editor. There's a lot of stuff in there you want to check it out. If you're on YouTube, there should be a link in the YouTube description where you can swing by and say hi if you're online between 2 and 4 o'clock Pacific time. Yeah. I think that's it. Like, subscribe, Twitch Prime. Let's say bye to YouTube, and Twitch, let's figure who we want to raid.